Josh Kuhn. I'm from RethinkDB. Has anybody heard of RethinkDB or used it before, played with it? OK, cool. So I'm going to talk about bringing lessons of Node to the database layer. So RethinkDB is the first open source scalable database for the real-time web. So we open sourced AGPL about 2 years ago. We have over 100 contributors since then. We launched on Hacker News. It was kind of like a lot of people ended up being interested in it because of that. And we're probably about 14 developers working on it in Mountain View. It's designed to be able to scale your queries from, so you write the same query whether you're doing it over a cluster or you're doing it on one machine. And so scaling is really easy because of that. We also make replication really easy. And so what is the real-time web? So you've all seen applications like this, Google Docs, that kind of stuff, where you've got interactivity going on, and your users need to be updated about what things are happening in real time. And so another good example of this is Slack right down the street. Everybody needs to be constantly connecting and talking to the server and with minimal downtime. So where do you need the real-time web? Some examples: marketplaces, streaming analytics, multiplayer games, collaborative web, mobile apps. So they need to use stuff directly to the user in real time. So on the web browser end, use Socket.io and you're done. You've got push, and it has some fallback to long polling, but basically you can push updates to your users in real time. So that part of the equation is pretty well solved. There's lots of different ways to solve it, but you can do it. Nobody's going to stop you from doing it. Node.js, is designed from the ground up to do make these kind of applications possible. It makes it weird and hard to do synchronous, I/O. So you're going to be, designing your applications naturally to do real time. And other languages like Tornado or Python has Tornado and stuff like that, where they offer those capabilities. But basically, by and large, if you're writing a web application, your server can probably do this real-time stuff. If it doesn't, you're going to have real problems. But the database is kind of a missing piece of that. So if you've got an Oracle web server, you're going to have a hard time getting real-time updates from your Oracle web server. And so we're the first database that's designed from the ground up to actually support real-time web. And so part of that is making it really easy to do. So there's the architectural end where we make it possible and fast and efficient. And then there's the developer end where you actually want to do it. OK, so real quick, an overview of RethinkDB, if you haven't seen it or heard of it. We have lock-free MVCC, so multi-version concurrency control, if that means anything. We also have distributed joins, so you can do joins between your tables. We're a JSON database, so maybe that seems strange, but yeah, sometimes your data is not entirely hierarchical, and you want to be able to do joins. So we offer that, and we scale it out as your cluster grows. Yeah, and as I said earlier, we turn your regular queries into MapReduce queries underneath and distribute them across the cluster. So you don't have to change your strategy for how you're writing your app when you want to scale out. We also have a really nice admin interface, which I think I'm going to show you. If I can, yeah. Oh, let's see. OK, I'll show you how to start the database. So let's see. OK, this is how you start RethinkDB. Oh, I'm not connected to the internet. That's interesting. OK. And then let's see. So we'll add another database, another server to the cluster. This is just giving it a port offset, so it doesn't try to use the same ports as the first one. And it's going to say join the other guy at the default port. OK, so both of them are connected together. All right. OK, so this is the web interface. So it just starts a web server on port 8080, and you can just, you have a really easy way to see the healthier cluster. You can look at the different tables in your cluster. Let's see here. So why am I zooming into this part? Because I wrote this part, and so I'm really proud of it. OK. All right, so we want to change. This table has currently 1 shard and 2 replicas, and we want to move it from up to 2 shards and 1 replica. So for those uninitiated, sharding is basically that'll speed up your queries. So part of your data is over here, part of your data is over here, and your server gets less load on it. And replicas are mostly for backup and disaster recovery, but you can also, if you're willing to get outdated queries, you can speed up your read queries if you want to use replicas. So this is telling us, we're going to move the servers around a little bit and how they're applied, and you can just run it there. And OK, so we've changed sharding and replication for this table, like really easily. So this is the web interface is pretty nice, and it comes standard with your database. So we have a really nice query language. Official drivers, Node, Ruby, and Python. And we also have some really nice community drivers for other languages that you're probably interested in. And one unique thing about our query languages, instead of being like a big text string like SQL or something, or being all written in JSON, we have an integrated query language that with custom built into each driver language. So this is the same query in the 3 different major languages we support. So you'll see basically you can use a Lambda from Python. It's the same thing, function here. Ruby has a lot of ways to make the syntax very succinct, so it looks a little shorter. But the idea is you write the query and it looks like this is you import RethinkDB as R, and you get to use this is just JavaScript, which is kind of nice. OK, so let me actually show you how that works out. So here we've got let's see, I'll do this. All right, so this is another nice benefit of the web UI is you can run queries right in the web UI and just play around with things if you want to see. So these, it's all JSON documents, but in this case, they're kind of flat. So the table view is pretty useful. And you can, if you're used to SQL databases, it'll be kind of familiar. OK, so let's do order by, and we'll do, oops. All right, so we order by score. And we don't actually want to order by score. We want to order by descending score. OK. Oh, look, I have 1,000,000 points. What a surprise. All right, and then we don't care about the whole thing. We're just limited to 3 people or 4. So this is it has a very similar feel to jQuery, where you just kind of chain and you keep changing your query. In this case, we could also use an index for score, because I built an index for score beforehand. And you get the same result, only faster. OK, so that's what the query language looks like. All right, so Node.js is designed from the ground up to do real-time stuff. And the reason is because it's event-driven and it uses coroutines underneath. And it's implied that it wants to be able to have thousands and thousands of connections. And so it's one of the things that makes it possible to do this kind of thing is that it's not doing anything when nothing is happening. The event-driven architecture really allows you to scale up because you're not doing a bunch of busy work. And it uses cooperative multitasking, which is really nice. It pushes if you're doing a lot of I/O stuff, you basically don't have to pay the cost of spawning threads and stuff like that, which is really, really convenient. And you also don't have to pay the complexity costs of mutexes and all the concurrency stuff that comes along with threads if you're doing a lot of sharing. that is sort of like assuming you're not doing a ton of CPU stuff. If you're doing a ton of CPU stuff, you kind of can't escape using processes or threads if you want to share. So yeah, so this is like we can't use threads, and this is why we got to use coroutines. And so web servers are mostly I/O. So this is kind of like, this is totally natural. This is why Node makes sense. OK, so why is RethinkDB useful for real time? So if we're building a real-time app, we're going to have WebSockets between Node and the browser. We get to push stuff. We don't have to have thousands of threads. We can have mostly idle connections to the Node server, and you're not going to have any problems scaling. But if you want to get like push to Node, how does Node get pushed information? Otherwise it's going to be polling something. If you're polling, you're constantly checking, and you're removing your ability to handle more requests because you're constantly doing busy work. So polling is kind of a bad idea. It works when you first get started if you're just trying to get something working, but then once you try to scale out, it really gets really slow. And it puts a huge load on your database and on your web server, and basically you're going to have to start, buying new Heroku instances a lot sooner than you would otherwise. So a lot of people use message queues because message queues are asynchronous. Put stuff on the queue, this queue pushes to Node, everything's push, and you've just kind of, really what you've done is pushed it sort of back into the message queue. But it helps because you've got the message queue is designed to handle a big fire hose of stuff. So we can you still have the problem of which events are relevant to which users. Who's going to sort that out? Like the application server is it's got all your logic in it, so that's a reasonable place to put the sorting logic. Okay, so I've got 10,000 events coming in, but only 2 of my users actually care about those, so most of this is just going to be busy work and it's thrown out. So this, yeah, and then you're going to scale out, and so now every single one of your application servers needs to take everything in, and it gets kind of ugly. So we're processing a lot of events that they're not going to be useful. It's kind of ugly. And you can get smarter. You can make different kinds of events, and you can set up queues and stuff, and you can get this to work. But it's very complicated. And it's going to be very specific to your app. Which queues are you going to have? Which kind of queries are going to go into which queues? Do I need to make a new queue now? It's sort of very specific, and then you're going to have to constantly kind of keep the complexity managed as your app grows. So yeah, so the fundamental problem here is that we've got changes coming in from somewhere, maybe from the app, maybe from a shark collar somewhere in the Pacific. We've got changes coming into your system, and you got to record them in the database, and you also got to send them out to anybody who's interested in getting live updates to them. So if the database is the source of truth in your application, so why can't we get the database to just tell us about what's going on? We have to send it to the database anyway, and so that's what change feeds do. They allow you to put, you're going to save your data to the database, and the database is going to tell you what's happening. OK, so this is telling me I should do the demo now. All right. So before we had a top 10 list, and this is OK. So this is a good example of something that's a little trickier than it seems. OK, this is the top 4 list. I lied. But it's a little trickier than it seems because let's say you get some new user and he just gets 10,000 points. You can't just update it in place. You can't say, well, it kind of if somebody falls out of the top 10 list, you have to know who's going into it. And that requires knowing all the data that's in the database. So it's sort of a little tricky to do if you're you can't just push, OK, this guy got a new score. Does he go into the top 10? So this is made really easy in RethinkDB because you can basically just take this query and do this. All right, so I'm going to go back to tree view. So what this does is it gives us our initial value. Here's all the people who are in the list right now. And it's listening for events. The way it does this is it leaves a connection open to the database server. So like Node would be sitting there listening to it. All right, so this was me before messing around. All right, so I'm going to set myself back to 0. Because clearly I cheated if I have a score that high. All right. OK, and so this by the way, this is connected to one of them, and this is connected to the other server. So any of your servers in your cluster can actually handle queries. So that's one thing that's really nice about scaling out as well. So we got new information. OK, so I'm out. I'm not in the top 10 or in top 4 anymore. But M. Lucy is in because he had a score of 140. And so now we can really seamlessly update like our top 4 list in our application. And it was really easy to do. We already wrote this query because we had to get the data out of the database in the first place. So now we just tack changes onto it, and we get to leave a connection open and get push updates to our data, to the query that we actually did on the data. Not just, OK, did anything change, and let me filter through all the changes that happened on the table and figure out what's relevant to me. Instead, it's, I'm interested in this top 4 list by this score. Tell me when that changes. All right. How much time do I have? 5? OK, cool. All right, so I've kind of hinted at this, but basically, like the database has some cool advantages that like other parts of your stack don't have. It knows which shards your data's on. It's already taken your query apart, and it knows which parts of the query are just transformations and which parts are dependent on which kinds of data. And it's able to look into a lot of parts that would be really complicated to do elsewhere in your stack. So this is like a question that might occur to you. If you have a Postgres server, you don't want to open 50,000 connections to your Postgres server. It's going to fall over and die because it opens a new process for every connection that comes in. And this is a perfectly reasonable strategy for most databases. Like most databases are going to do a ton of CPU bound work. And so it doesn't make sense that like just use threads. You don't need to go through the complexity of building a coroutine system into it because you're not going to be able to take advantage of it. You only have so much CPU time, so there's no point in sharing it between 10,000 connections. But RethinkDB actually, we built coroutines into it at the bottom layer so that we could allow you to leave connections open to the database for exactly this reason, so that you can get, like the same way Node can have lots and lots of idle connections that are I/O bound, we can do the same kind of thing for change feeds. So it's actually totally fine to just open 1,000 connections to RethinkDB, and then when you open another shard, open another 1,000 to that shard. Yeah, so this is what I kind of skipped over. And this allows you to have basically like the event-driven stack, which is like the holy grail. All the way from the database, all the way up to the front end of the client, you can have real-time updates. Everything is push from front to back, which no other architecture kind of lets you have right now. One limitation we have right now is that we have all the things in the map step can be change feedable. If you have from MapReduce. So we've got map. We are working on reduce. That is the next part. But like basically, we intend to make all of our queries change feedable. So just like I showed you before, like where you just wrote your regular database query and tacked dot changes onto the end of it. Eventually, we want to have that for absolutely everything in the database, so that like whatever kind of query you're writing, RethinkDB can give you updates to that in real time and do it really efficiently and scalably. OK, so we're the first open source scalable database for real-time web, and it makes real-time app dramatically easier. Yes, exactly what it says there. OK, so if you're interested, check out RethinkDB.com. You can download it. As I showed you before, you just download it and install it and type RethinkDB in. It starts running. It gives you a web UI. It's really nice out of the box. And if you have any questions, we're on Twitter at RethinkDB. We just released our 2.0 release candidate, which is going to provide long-term support. So it's a really good time to get involved. And we have a meetup on March 30th for the 2.0 release. I think we'll release these slides afterwards, so this should be the link. But we're at HeavyBit on March 30th, if you're interested. And any questions? Yeah.
So just to walk through like a typical flow here. So the client, the browser, opens up a website connection to the Node process, and then the Node process opens up a connection, a RethinkDB blocking of some kind, right? So it's just one connection for your Node to the DB, right?
Yeah.
So the clients could be thousands, but the actual Node process is just one connection, right?
You can have one connection per user if you wanted to. We also support multiple queries over the same connection, so you can reuse the same connection for like all the queries for one user. But it wouldn't be bad to open lots of connections.
Okay. So note that when it's blocking on those changes, it's actually blocking waiting for changes then, right? When you call .changes on
yeah, exactly. It's
in Node.
Yeah. So underneath it's blocking, but it's I/O blocking, yeah, so it's able to handle a request in the meantime.
When things change.
Yeah.
Like a changes callback or whatever.
Exactly. Yeah. So right. So this is like JavaScript from the data explorer, like I showed you. Like in the actual driver you'd use in your regular Node stuff, you'd have like .run and then you'd give it a little callback. But we have to make it synchronous for the data explorer and the web UI. But yeah, it's very similar. Yeah.
What sort of data models is RethinkDB like best at dealing with?
So we data okay. So
I mean, I don't know what's under the hood, but just like what does it excel at?
Okay, yeah, I need slightly more detail. Sorry, I'm just confused.
I'm guessing it's not a graph database.
No, it's not a graph. Yeah, so we do. Yeah, so we can do time series. We have geo queries, so you can do location-based stuff. Yeah, so we have a couple of forays into that, but basically anything you can do, JSON modeling, anything you can do in relational database too, because you can do joins. So really, yeah, I would say probably the biggest thing that we don't do is graph. But yeah, you can kind of press it into service for whatever you need. Yeah.
So you talked about sharding and stuff like that. So that would mean distributed joins, right? So
yeah.
I'm wondering, what are the problem cases? I mean.
So in what?
Well, I would think for distributed joins, so you're doing MapReduce, or I mean.
Yeah.
Are you going to run into performance issues at some point with the sharding?
I mean, you can't escape the laws of math eventually, ultimately. But like, yeah, we make it as easy as possible. I don't have the specific details on the algorithm behind the distributed join. I just know that they're distributed join. But I can get you that information if you're interested.
Can I create the index on the fly?
I'm sorry?
Can I create the index on the fly for JSON?
Oh, yeah. We can.
It's so important for us.
Yeah, we have. So I just like came down here and. All right. So we don't even have a field name foo, but it's a JSON database. So there we go. And I have a data.
When you do that, does that lock the table when you create the index?
I forget. I don't. Certain things. Yeah, I forget. Sorry. Yeah, depending on how much data you have, this can take a little while. But I don't believe it actually. I think you can't use the index until it's done building. Like it won't let you use a partial index, but I don't think it actually stops the table from handling reads otherwise. But don't quote me on it. All right. Any other questions?
All right. Thanks.
All right. Cool.